All right, here we are again. This is going to be a good one. I'm excited for this one.
Me too.
That this will be good.
Power and speed we are, right?
Oh, yeah.
908-75102. Yep, I did.
I saw you choke.
I was on the limiter.
I was going to throw you a life preserver, but I figured I'd let you sing for
908-751-0211. Like as if you guys are going to call in. I know you won't. And Tad?
Like us on Facebook. Call in maybe. And iTunes too.
Yeah.
Fantastic, Tad. Great delivery.
Yeah, whatever.
It was good. He got the call in.
Yes.
It's a step up.
I want to hate on our guys for a minute.
Our guys?
Our guys.
For not calling?
Like us?
Yeah. No, not the guys in here.
Oh, okay. Yeah, I was going to say it'd be fucked up to hate on us.
Our live listeners?
When we have something like posted live, that like what's going to be live, like a guest.
Yep.
It's kind of weird. Like certain times, all of a sudden the thing will be viewed a lot.
Yeah.
And sometimes won't. We talked about it today.
Yep, we did.
Directive to all the listeners. They're being dispatced.
Yeah, I know. They're going to be happy about that.
Yes.
Usually you just ask them.
That'll be a t-shirt. Mike has dispatched me. If it's something that you think is interesting and you got other car nitwits hanging out on your Facebook, if they share it, then it gets, I guess, and so
it multiplies,
on.
yeah.
Right.
Yeah.
Right. So don't be afraid to share our stuff. I mean, we want people, and we do want people to call. I mean, sometimes with guests, it's tough because we don't have a call screener. Alan was, we won't even get into that.
Yeah.
But, we do encourage people to call, to interact, send questions on Mixler, send questions on Facebook. I mean,
why can't they do questions on Facebook?
Well, because, here's the problem.
Are they lazy?
Hold on. Want to go on record again.
I know you don't look at it.
I am not the fucking Facebook guy.
Okay. Well, that just because you don't look at it doesn't mean that they can't post them and me and Tad won't see them.
Oh, okay. But I don't even know how you do that. I know that shit shows up on the side.
Dude, we're not asking you to do it. The listeners know how to do it.
Can they do it?
Yeah, they can.
Okay, well then listeners do it. Tom has dispatched you now.
And that is good for a shirt. You've been dispatched. I like that.
That is good, yeah.
I know. Yeah, they can ask questions. And we get notifications.
Yeah. Yep. And one other thing that we have to address is the vacant seat.
Yeah, we do have a vacant seat.
Yep, I forgot. And we started, and I was going to be the first thing. For Crunch, his time has gotten tough, and it's been tough all the way around.
It has.
Because I work, Tom works. I don't know what Tad really does. We think he just lives at a White Castle somewhere.
But
I think he does.
But Crunch has a very long commute.
Yep.
So then we move things around trying to make it easy for everyone. And for you, Tom, it always seemed like a Monday was good because of travel time.
Yep.
If you have to travel for a trade show, or I had to travel for a trade show for the most part.
Yep.
I would be back by Monday. Hopefully I'd fly in Sunday. Yep. Same with you.
Yep.
Tad, where do you go? Nowhere. So it's really, you're kind of open.
So you fly in Sunday too?
Yeah.
From White Castle.
The one by you wasn't that bad.
Yeah.
So we decided on Mondays because for Crunch, it was, somewhat of his lighter day.
I thought it was his best day. Yeah.
And to get here, but it was getting tough for him to get here by 7. And now we decide, what do we do? Do we try to push to 8 o'clock? Well, that doesn't work for Tom because he's got family. I mean, it just gets all effed up. So look, he's more than welcome to call in or come in or whenever he's got time or whenever it works. I mean, seats open. We're not like we always joke around like, well, we could replace Tad, but we're not looking for a replacement. If things work out better for Crunch, that he can make it here. Have at it.
Yeah, and hopefully he'll at least call in once in a while from one of his races.
I hope he does. I really like the guy, man. He's I've known him for so long, and he was like probably one of the very first people I met at street racing at Newark. Yeah, he really went, and he's a great dude.
I like him too. Good heart, friendly guy. I mean, I hope that look, if he's making money, good for him. But again, Crunch, if you're listening, buddy, I'm sure you are. Feel free to call in. Feel free to stop by. You certainly know where it's at. And you know when it happens. Yep.
So do what you can do.
Yep.
So with that out of the way,
Tad.
Yep.
Nothing to add.
I'm just listening.
I thought I was going to say like us on Facebook.
That's half the friggin' problem. You
Actually,
just
call us. No, yeah.
You just kind of sit there and listen, no matter what we're talking about. We got guests, and I look at you, and Tad's just looking up at the ceiling.
Let's paint a picture. Tad's always got that nobody home look in his eye.
Yes.
I'm just listening to people saying, "Oh, we're going to replace Tad." It's like, "Oh, cool. I can go home and sleep."
You wouldn't, but you'd go home and eat.
Yeah.
Well, it's a given.
So tonight we have Keith Jones from Total Seal.
Yeah, we do. Keith is going to be a good guest. You know, I talk to Keith all the time, so I'm probably not going to interact much because what our listeners want to hear, I probably talk to him, you know, weekly about. We have ring issues or ring questions or anything to do with a piston ring. He really is the man.
Yeah.
Yeah, I mean, he I believe he's their number one tech guy. They send him all over the world. I mean, he goes to all the shows, to Germany, to England, to Japan, to, you know, Wisconsin.
Any place a ring is required.
Yeah. He might have been to Utah.
You know, it is such a deep subject. I had said this to, I think I was talking to Tad. I don't know if I was talking to you or I might have been talking to Fudd. I don't remember.
Fudd's listening, by the way.
Is he listening?
Yeah.
Hi, Alan.
Hey, Fudd.
Feel free to call in and ask your questions. We won't pick on you, we promise.
Yeah, and I'm not going to be hostile, Fudd.
Yeah, Fudd doesn't want to call because he thinks we're going to abuse him.
Yeah.
And I don't want the callers to think we're going to abuse him either.
Well, we're going to abuse Fudd, but just not hostily.
All right. Fair enough.
Yeah. He knows that.
In the short block area, there haven't been huge advancements in anything that I would think of other than revolving around the piston, the ring, the barrel of the piston, the hone. I mean, that's where people have found power. I mean, I know that if, kind of we knew then what we know now, that all our stuff would be incrementally better than it ever was.
Yep.
And those are really the advancements. I mean, could oil pans have gotten better? Sure. Could crankshafts have gotten a little lighter, maybe a little more aerodynamic? Maybe they learned a little bit. And same thing with connecting rods.
Sure.
I mean, how much is really there? On the other hand, bore finish, all methodologies for making the cylinder seal, that's where all the magic is in the short block. That's the important one.
I'll tell you, the magic in an engine, from what I understand, is behind the valve and in the ring lands.
Yep. Because you're
all of it.
You're trying to efficiently use everything you can get in and get out.
Yep.
And
actually, I did hear some stuff from some guy who will remain nameless about piston shape.
Okay.
That you and I got to talk about it off the air because I can't talk about it on the air. But it is pretty cool.
Okay.
Yeah, it's different. You'll understand it.
I don't know about that because, like, we always talked about, cam and barrel and everything. I was like, okay. Yeah, I mean, I certainly know pistons aren't round. I know why they're shaped the way they are.
You're gonna understand.
Okay.
I know you are, just based on some of the things that we did to your pistons back in the day.
Okay.
When you saw some stuff happening and we did some stuff, it's on the other side, but you'll get it.
Okay.
Tad, you won't. We'll talk about we'll talk about Roy Rogers after the piston speech.
So I mean, I have a lot of questions, and I would hope that listeners do too. And this is what I always struggle with. Do people that mess around with cars wonder about things as deeply as I do, or do they just know I need a piston, I'm going to buy a ring, and I'm going to put it together?
You talking about car things or Taylor Swift things?
No, she's getting a little old. I might have to back off that. No, but I mean, like I wonder, like I think about piston rings and I think about how things work, and I'm always trying to figure out if something could be better. I want to know why everything works. Do our listeners think like that, or do they just put the thing together if they do their own stuff, or did they just buy it from an engine builder and say, I don't have to worry about it, I buy it?
There's probably a mix of all the above, if you think about it. I mean, I don't know, like, I'll give you an example. I know one of our listeners definitely thinks about it.
Okay.
Jeff Chang.
Okay.
I mean, because I know what he does. I mean, he's basically got a little machine shop in his garage.
Okay.
And he washes parts in an old dishwasher, and he hones his own stuff with a torque plate, and he knows about ring finish and cylinder wall finish and ring fit. And so he's probably the exception.
Mm-hmm.
There's probably a bunch of guys that are in the middle. And then there are some guys that really just don't care. They want to call IAG or
right, but
LME or whoever and get a motor.
This kind of falls in line with like my wisecrack about women in racing. Like why, to me, if you understand fundamentally everything that's going on, you can make better decisions as a consumer. And you can better diagnose what goes on. Just like if you understood how a car worked, you tend to drive a little better than the person that says, the red thing is at 7 and it's 7 with 3 zeros. What does that mean?
Yeah. Yeah.
You know what I mean?
Yeah. That's your fun meter.
Yeah. So I
I hope that the listeners come up with some questions. You looking at Mixler? Does anybody have anything for when a guy come in, or are they just all being quiet?
Yeah, Jeff Hester has a comment. He said, "Boom,
Boom."
Yeah,
fantastic. Thank you, Jeff.
Yeah,
good contribution. All right. Well, I guess the other thing we should talk about too that we didn't talk about last week too much is that Tad Subaru is going. It's going to go down to the
going to Precision to get a
Precision. It's going to remove the motor. Hopefully they know about this. Or surprise if you're listening.
No, I've talked to him.
Okay,
I have.
Going to go down there, get the motor removed, get the rest of the parts to JJ, and hopefully get Cletus here back on the road.
Dismantled, reassembled.
Yep. And then where does it go from here? To body shop? Get all cleaned up?
He doesn't want to do that.
He just
wants to be a sleeper.
And I noticed I came in the other day and he had moved his car to a new location and put a hood scoop on it. So not the stupid power hood scoop. He put a real Subaru hood scoop on it.
A stock hood scoop that doesn't fit in the hole in that stupid carbon fiber hood. So a faux carbon fiber hood.
But you are going to make just a cover for it, right?
I just want to get a stock hood again on it. I want to get rid of that thing. Yeah.
Okay. Good. Yeah, that'll be good.
I mean, you can't put a nose on it that ain't broken.
No.
I mean, I don't think that's too much to ask. You can
put
keep
a new
it
nose
silver.
on it, and the deer is going to go whap. That's it. Guaranteed.
That's like saying you don't change your drawers because tomorrow they're going to get dirty anyway. Come on, Todd. Seriously?
That's not like saying that.
It is like saying that.
I've hit so many deer, I just don't bother anymore.
I'm just shaking my head.
Yeah, I know.
I need the cricket sound effect. Anyway. So,
and then we talked about Howard real quick. We have to have him back on.
Yeah, he wants to come back on. I talked to him for like an hour today.
And I have a special message for Howard if he's listening. Just spend the money and go upstairs, Howard.
Yeah.
Spend the money, go upstairs. I'm sure he knows exactly.
He does.
Yeah. Spend the money, Howard.
We'll talk about that tomorrow.
It's just money.
It's funny, actually. They're having Howard. They asked him to build the trophy to give to this year's winner.
To build the trophy?
Yeah. Last year, somebody made one out of they torch cut steel and welded pistons and
old car parts and stuff.
It's a cool artist rendition of
Hopefully he has more artistic ability than I do.
Yeah, or me. I know. I would just glue some shit together so Howard's doing that, and then he got pleasantly surprised today that we're going to bring him out there and he's going to actually award the new winner.
Because he did win it last year.
He won it last year. He crushed it last year. He really did.
Yeah, that's what you said. You said it was kind of embarrassing. It was bad.
Yeah, like after the first pulls. After he made a pull and the other guy made a pull, it was over because there was just too much spread. You couldn't make up the average.
Now this is to what show?
Custom Show Emirates.
Yep.
And shout out to them too. I mean, that show's coming up. It's the end of March. We're flying over to Abu Dhabi and we'll be in Dubai. And it's a big show.
And listen, if those guys want to fly in a radio personality or a podcast personality, I might be available.
Okay. I'll check on that. He told me.
I'm not flying in the landing gear area. I want to make that perfectly clear.
No, I was talking to Saeed today, and he was telling me about all the television coverage they're getting this year.
Oh, nice.
I mean, Japan, China, Great Britain, Germany. There's going to be
North Korea.
8 TV. Yeah, North Korea. What's his name's going to show up there? Himself?
Kim Jong?
Yeah, well, he builds the best motors.
Oh, yeah, well.
And he set the land speed record, I believe.
We can go down the list of things that guy's accomplished.
I think he's got 18 holes in one.
What a fucking nut, huh?
Yeah, he is. Total. That's batshit crazy, I think they call that.
All right, well, that's good. It's nice to know that they're going that well with that show. I mean, you said it's amazing. Said it's beautiful, that there's nothing, that you couldn't imagine anything like it. So,
yeah.
If anybody can get there, if they really want to take that kind of trip, it's a hell of a trip for us, but I think it'd be worth going to. Well, I'd like to go.
Why don't we? Come on, man.
I would like to
You've
go.
said that to every place I've gone in the last 6 months.
I know, but
you're don't count me out. I'm going to hey, California, I'm going to go.
When is this one?
The last day. I'm leaving the 28th of March.
Oh yeah, I'm not making that. I'm not. I'm going to be still all egg shaped well after that. I've got too much shit going on. There's no way.
Yeah, I know.
All right. Well, we babbled long enough. I see Keith from Total Seal is here.
Yes, he is.
Let's bring him in. Keith, you there?
Yes, I am here. How are you guys doing?
I'm all right, buddy. How are you?
Excellent. It's we'll say it's all good here in Arizona. Another crazy Monday, and we're back at it.
I bet you have just fantastic weather out there.
I was just going to say that. It's
actually getting the way it should be. We've been running about 15 to 20 degrees above normal.
Really?
So we've been running kind of 85 to 90, which it should be in the low to mid 70s. So we'll just say, being a Phoenician and having to deal with 115, 118 degree weather in the summertime, we'll say this time of the year we're absorbing as much cool weather as we can so we can make it through the heat without combusting into a flame. And we're not getting enough cooling absorption this time of the year. It's been too hot, but It's going to be 70, 72 the next couple of days. And then, hey, guess what? Right back into the 80s.
Nighttime's cold? Like, does it get cold there at night?
Yeah, it will. In the wintertime, you can actually get into the teens, low 20s, high teens at night. The last few years, we haven't had weather that cold, but it will get into the 30s. A typical winter, you get some couple of days, maybe high 20s, low 30s, maybe a week of cool weather. But after that, it's pretty much all good.
Yeah, well, it sucks here in New Jersey. I could tell you, it's all over the place. It's just not good.
Yeah, you guys are all over, but it looks like you're going to have a short winter. At least it looks like it's going that way.
Yeah, we got one snow, and I think that's probably it. And they're saying nice days coming, so hopefully it gets here sooner rather than later.
What'd the groundhog say?
Yeah.
I don't even pay attention to that shit.
He said a short winter. I remember that. It was going to be the short one.
How does he know that? I'm.
Hey, you got to trust Puxatawny Phil. He knows.
Keith knows everything. I told you he's the man.
Well, hopefully he can answer all of our ring questions, because I know that I've got, as Alan would say, a pant load. I have so many ring questions.
Well, glad to be able to help you in any way I can.
Keith, I dealt with you years ago when I first started. Like Tom had been breaking our nuts to start using Pistons, his 2-barrel stuff, and it was a whole big, long, and involved story about how to get in with his Pistons. But we had some issues that we wanted to explore on our side, just of course in that process of making things better. So can you tell the listeners a little bit about Total Seal, what you do, and just give us the general background? Not that people should know, but in case they don't.
Well, sure. Just a quick background about Total Seal. We started, I guess, as you want to call it, officially as a company in 1967. Started by a gentleman by the name of Joe Moriarty, who's still there. It's still a family-owned company to this day. It's been in Phoenix from day one. Joe actually did some engine development work for GM in the 60s on a rotary engine, not like a Wankel, obviously. That had already been developed, and we actually still have this engine at work. We need to put it back together, but we do actually still have it. And the gapless piston ring, that we're kind of, is kind of our claim to fame, is where it all started. That's where it began, was out of that part. And it literally is so many stories from back in the 60s. In those days, started as Joe's garage, as we like to affectionately call it. He started making them out of his garage and selling them to guys going down to the dunes for their Volkswagens, and it just kind of started growing from there. And the story kind of goes that it really, what I'll call, broke open when Hot Rod Magazine did an article about us in the early 70s, and that's kind of how it all began. And the company has been in Phoenix, like I said, ever since that point in time. I came to the company in 1997, so I've been there not quite 19 years. And at that time, we pretty much concentrated on doing the gapless piston ring. Well, myself, again, I came in, Matt Hartford came in a year behind me, Ed, Kevin, the other guys are, well known there. And we're like, hey, the gapless is great. I love the gapless piston ring, but we have to be able to do more. We have to be able to do all piston rings, and we have to be able to do them better. We have to figure out a way to make them better than everybody else. And one of the first phone calls I made was to Warren Johnson. Knew Warren from my days prior to Total Seal with GM.
Very good first phone call to make, I would say.
Yeah. Well, thank you. And I literally, at that time, not knowing a lot about piston rings, I know them, I use them, they go in my race car. It was about the extent of my knowledge at the time. I asked Warren right out, what don't you like about what you have now? And he goes, well, I'd really like 8 pieces to actually be the same. I go, well, what do you mean? He goes, well, measure them. He goes, take 150, 200 rings. He goes, measure them. He goes, you won't find 3 or 4 that are exactly the same sizes. They're all over the planet. And that's where it all began. That's where, Matt and I started looking at how they're made, the production methods, and what can we do to improve these tolerances? How do we make these specifications better? And that took us down an entirely new manufacturing path to the point of developing all our own equipment, our own manufacturing techniques, different than what I'll call the status quo has been for so many years, on how to be able to hold much, much tighter tolerances. At the same time, we also started working on the gapless top ring. What a lot of people don't know is that the Total Seal ring, the gapless ring, actually started in the top ring group. That's where it began. In the early 70s, they were having some problems with the rings breaking, and they thought it was a material problem. The material just wasn't good enough. So Matt and I started playing around on the dynos and working with some different guys, testing gapless top rings, making them out of better materials. And what we found, it really wasn't the material, it was the end gap. The gapless top ring stops the heat in the crown of the piston. It has to have more room to expand. And what we figured out was the gapping recommendations just weren't generous enough back in those days, and they were butting the ring ends and breaking the rings. And once we established some gapping parameters for the gapless ring, we reintroduced that part, and we'll just say it's still here to this day.
Mm-hmm. Mm-hmm. Tom, are you paying attention? Tom, I'm just watching Tom type on his iPad.
He's getting questions from the...
Yeah, I'm getting a million questions. You're at the helm right now, buddy.
Okay.
I talk to Keith all the time.
Nice guy.
So,
yeah.
And again, well, just to keep going on that, one of the things that we did, of course, is, again, pushing the manufacturing, tolerances. A typical production piston ring, if, everything has we'll say a governing set of rules, and we live by the SAE, Standards of Automotive Engineering.
Well, let's go down that road for a minute. If you were going to get a top ring and you wanted let's say a custom top ring, I know that in years past you used to order, before Total Seal was in this area, that people used to order either rings that you get Child and Albert, which were, an individual type ring, or they'd have to contract with a company like Seal Power to make a sleeve of rings. That's how the guys would usually get them. And I can't remember what a sleeve was anymore.
104 rings.
Okay. Yep, I remember that.
And that's exactly the comment with Warren, that he would buy sleeves, and Kurt, as we all know, Kurt Johnson, Kurt would sit on the floor and measure all of these rings and group them into groups that were similar sizes.
Wow.
Yeah, and then, of course, you'd get them to where you wanted in sizes. Then if you're trying to be really good, then your ringlands have to be right for each group.
Right.
It was a bad scenario.
Yeah,
I mean, I remember all this with
or
Pro
you
Stock
lapped
stuff.
them.
Yeah, but I mean, I don't even know what his thought on what Keith's thought on lapping is.
I know what his thought is, but go ahead, Keith.
Yeah.
What
Well, that's a big part of what we do. I mean, we looked at how rings were made, and how rings to this day at most operations are made is through a Blanchard grinder. They Blanchard grind the rings. It's cutting the top and the bottom surfaces, and you come out with a ring, and it's a reasonable part when it's done. It's going to fall within SAE spec, which is plus or minus 5/10,000. So, give you for instance, a 43 ring. A typical 043 ring is going to be 42.5. That's the mean number. Within spec, that means the ring could be 43.0 on the high or 42.0 on the low, and be within that, that 1,000th window spec for the tolerance. We looked at that manufacturing process and said, yeah, we can definitely do better. And we developed a multi-stage lapping system. Instead of grinding, we lap our rings on the tops and the bottoms, and as well on the faces. The ring faces of our products are also lapped.
Really?
To eliminate any imperfections. Yeah, all our rings are face lapped. But within the top and bottom lapping specifications, we can actually hold 50 millionths tolerance on these things. So we can hold an extremely flat, very tight tolerance part by just I shouldn't say just, but through developing better manufacturing techniques. One of the interesting things about us, if you look at some of the OE suppliers out there, and there's some good companies and they can produce good stuff, but their main concern is the OE. That's what drives them. In the global consumption of piston rings, you take everything piston ring that's related to what we would consider the performance or racing marketplace, and as a global consumption, we consume less than 1% of the product made in the world.
Yeah,
we're more of what you'd call the fly in the ointment than anything.
Wow.
At the OE levels, there's plants out there putting 750,000 rings a day through their plants. Massive production operations. We can do about 1,200 rings a day through our place. So, we're running at a much slower speed, and we're not. For us, it's not about the volume; it's about the quality.
Yeah, they don't hold a half a
Putting
tenth.
out a very tight tolerance part.
Wow. I did not know all your rings were lapped in those fashions. I mean, like we would always see, here's a problem coming from the engine building side. We know how some people would attempt to lap a ring and there's obviously ways you should and should not do it. And we've seen it done badly many times. Wow. That's right. And I mean, I guess that is the best way to get told the tolerance is.
Well, it's the only way. Sneak up on it and
wow.
Group them.
Well, and I heard what you said, sneak up on, and that is how we do it. It's a multi-stage system, and we're taking finer and finer steps. And like you were talking about, the hand lapping of rings. And there's guys out there that that have hand lapped rings for years, and they're typically using a surface plate with some 400 grit wet and dry and a little holder to lap it, and they're lapping one side of the ring. Well, as you already know, if we're not getting the pressure even all the way around, we're going to take more off one side than the other. Our system, we're working both surfaces at the same time. So we always keep everything square, in check. I'm working the top, I'm working the bottom. And, they're machines that we developed ourselves. We'll just say, if you're ever in Phoenix, come on by. We'll give you the tour.
I would never imagine that you've got, 30 guys in the back with a, with a round puck on the surface plate, with a little bit of lube on. I doubt it.
Next.
Exactly. Got rows and rows of guys just sitting there making their, looking like Popeye on that thing.
Well, I'm gonna take that tour one day, but let's get to some questions if you don't mind, sir.
Absolutely.
Because we got a lot of them here. I don't know if we're going to get to all of them now. We got so many. But, one of the things that our guys ask about all the time, and you and I have talked about this many times, is the break-in. Engine builders are always putting out like, no boost until 500 miles or don't do anything for 1,000 miles. And, Mike and I have always contended that when a cup motor goes together, it goes out onto the racetrack or goes to the dyno room and gets wide open throttle. So the rings either are in or there's something wrong. You're the expert. What's your thought on break-in?
Well, it is extremely important, and there's a lot of great things to be said about break-in and proper break-in, and that's, I guess, the real key word is proper. To give you an idea, at the cup level, though, even at GM, their 24-hour, they go through a very, very stringent break-in process. But it's not just about the piston rings at that point in time. I mean, a cup engine will go through typically about an hour to an hour and a half, what I'll call loaded cycle. These are all computer-operated dynos. It's going to have a cycle that's going to load the engine, various amounts of load up and down, kind of simulating a race-type condition. And they're going to do that. Then after they go through that cycle, now they're going to start doing power polls, step testing. That you would be amazed at the amount of time that is actually put on one of those engines before it ever goes in the car. You would think by the time it actually came off the dyno, it's ready to be rebuilt, but we'll see. But it's not. It's ready to go racing. And even at that, again, the amount of post-race dyno work that gets done to see how it's performing, after it's 500, 600, 1,000 mile, whatever the increment is for that particular customer, to see how it's done. But it actually goes through a lot of dyno work beforehand. But that's not all about seating up the rings. Like you said, generally speaking, if everything's correct, cylinder finishes are right, all of these things are right, they're usually pretty much in right off the bat.
Right.
I'll tell most customers that we'll just say aren't doing that kind of a program that are using a regular dyno. If it's not in 2 to 3 hits, generally speaking, we've got a cylinder finish issue because the bulk of what you're seating is the cylinder. We pre-lap the ring, but we've got to get the cylinder in the ring to become what I'll call a mated surface. And the bulk of that work is actually the cylinder. And if you really get your cylinders right, they're in 2-3 hits. That's it.
Mm-hmm.
You got an engine on the dyno that you've got 15 hits, and boy, she's getting better. Man, 22, and it's really coming around. You got something seriously wrong.
Exactly.
Yeah, and that's what we always did. Like if we were running a super stock motor or a comp motor, it was warm up, get it up to temperature, go over valve lash, make sure everything under the covers is good.
Yep.
Make sure the room's clear, and then bring it up and make your first hits. And then in the first 2 or 3 hits, it would seal up, and that would be it. You'd be done.
Yep. You make the best power run.
Going to get
best power on second or third hit, and then you play with.
Actually, we always found they got a little better and a little better and a little better. Probably in a drag piece like the super stock stuff back then. Now, I don't know what Keith's feeling about that is, but a lot of them were like stainless dikes is what we'd use.
Mm-hmm.
And they'd seem like they'd be good about like the 20th pull. Like you'd say, the thing would never get any better. That's as good as the ring side's going to get.
Well, oils and ring sizes come into play, and it really does take time or a ring to ultimately seat all the way in. You can get really, really good results right off the bat, but to get what I'll call all of it, now it takes some time. Generally, you got to get in a race car. It's really difficult to put, that kind of load for that kind of period of time on a dyno. I mean, you think about a 15-second long pull. That's a long time on a dyno. But in the car, that's really not that much. We've seen GM, like their 24-hour Le Mans stuff. I've seen, hours and hours and hours spent on the dyno. Great power, really sealed up, very good numbers, but yet ultimately another hour into the actual race, we've hit peak pan vacuum, which tells us it wasn't, it was very good, but it wasn't all there yet. It still had a little further to go, and that's, like I said, it's really difficult to do that on the dyno. That last little bit almost always comes, from being in the car.
Yeah, well, that makes sense, but and I agree with all of it. But my point here is, guy puts his 4G63 together, with some kind of little turbo in his Evo 9 or Evo 8, and he takes it down the road, and the first 10 miles of driving are more dyno time than that engine will ever see.
True.
So, that's what I'm saying. Yeah. The 1,000-mile break-in thing is what I always, listen, they want to say it. It doesn't hurt anything, but I always just thought it was funny. Because
it's interesting. What I see so much these days is just, we'll just kind of go over break-in. We'll just kind of hit that real quick. One thing I'll say, like on an engine dyno, normally we'll run them about 10, 15 minutes with a reasonable load on the motor before we put a hard pull on it, just to give it a little run time. And as you were saying, I'll come off that, then I'll check the valves. You'd be surprised how many times we found a part that if we winged this thing 10,000 RPM would have been stuck stuck through the wall, but we found it, valve spring going away, whatever, in that first 10, 15 minutes. So I always like to give them a little bit of loaded run time, just kind of let them run, shut it off, check everything, check my springs, check last, check everything, and then, as I like to say, let the beatings commence. The other issues that I run into, one is a problem, is run stands. I get a lot of guys that take this stuff and they put it on a run stand.
Well, then
and they
you mean like a no load, just running?
A no load running. It's got a radiator and that's it.
Oh, God.
And they'll run this thing for a half hour, 45 minutes, an hour. This is one of the worst things you can do. It's unloaded run time. This is putting a lot of fuel through the engine that's not being burned. And that breaks down oil film, creates cylinder problems. The bottom line is you want to get a load on it as fast as you can. Unloaded run time is not good time for rings. Rings like to be loaded as quickly as possible.
There you go.
That almost always gets you sealed up really good. And then you've also got to watch additives and oils. What's interesting with, there's a lot of trick of the week break-in oil stuff out there right now. I'm not trying to pitch brands, I'm not doing that, but we do like the Driven products. We've had excellent success with the Driven products. Really think there's a lot of science behind their stuff. But with that said, rings, unlike camshafts like a lot of anti-friction compounded oil.
Oh, God.
We want to cut that friction. Rings actually kind of want friction. They want anti-scuff. So it's a matter of finding a product that's got, we'll say just like the Three Pigs, finding that one that's just right. Right amount of anti-scuff, right amount of anti-friction. And one of the biggest problems I run into is all the, I guess it's kind of like internet self-diagnosis. All the guys that are blending their own, they'll take this brand of oil and then they'll add some Rizlone and then they'll put some Marvell in it, and they're creating their own little concoction. You got to be real careful with that. A good oil or a proper oil doesn't need you to do anything more to it. All of that's already been engineered. I had one particular customer added an additive to some oil on an HRA stalker, and the stuff literally turned into jello on the dyno and shelled the engine. It completely plugged it. So be real careful with what, pick a good break-in oil, stick with that. It generally doesn't need you to help it.
Okay, that's good information. I mean, we always used, honestly, 9 times out of 10, Pennzoil 1030, and once the oils changed, we always used a little bottle of GM EOS, because we were doing a lot of flat tappet stuff. We were doing a lot of 2-barrel circle track stuff. And, all flat tappets. And then, you start to have more and more respect for the cup guys, like how they got to Stellite cams and tool steel cams.
Right. Yeah. Now the cam deal matters less because it's all roller cams.
Yeah, all roller.
I think they're focusing more on the cylinders.
Sure.
But I always use Rotella because it always had the good additive package.
It's a good oil. Oils, bottom line is I like to see big brands. They're making it in big batches. You got consistency batch to batch. and I'm not picking on any brand of oil. It just, the problem I get is when guys start buying, I'll give you a quick story here. I had a good guy, his name's, and hopefully, I don't know if Gordy's listening, I don't want to throw him under the bus here, but Gordy Rivera, old-time pro stock racer. Gordy's a good friend. And we'll just say one of the tricks back in the day, and this is kind of where I'm going with, being careful with additives, a trick was to put a Teflon additive in the oil. You get the engine, he's sitting on the outside looking in at the show and goes, man, I'll put a little of this in oil and it'll pick up. And Gordy did. He put some in and it picked up. Well, if one container is good, two must be better. Well, I got a call on my cell phone sitting here, and hey, Keith, it's Gordy. Hey, Gordy, what's going on? He's over promoting it. It won't make enough compression to even start.
Wow.
It has lost ring seal so bad.
Well,
my point is, you got to be careful with the additives.
Well, let's do this because, and I mean, this is going to be probably the most basic question I'm ever going to ask. But could you explain to the listeners what makes a ring seal in the motor? Like where does the sealing actually take place? What are the important areas and how? That's probably the best to clear things up for some people.
Well, sure. So rings, it's a very interesting scenario here. Rings seal on the oil that's retained by the cylinder wall. Rings ride on a film of oil, just like a bearing does on a crankshaft. The only time you're actually going to have what I'll call true contact of cylinder and ring is on a cold startup. Whether it hasn't built a wedge of oil. Rings run in what's called a mixed boundary lubrication effect. There's a very little bit of contact, and there's a number when we're measuring cylinder finishes called the RPK, or the peak roughness. This is what the ring will actually have contact with, but it's a very, very small amount of contact. It's the oil that's between the ring and the wall, and it's riding on that very light wedge, just like the skirt of the piston is riding on that very light wedge of oil. And that's where the ring seal comes from. Now, to aid that seal, we've got to get combustion pressure behind it. Again, back to that heat and load. We've got to get the combustion. You're dealing with cylinder numbers that can peaks at 20,000 pounds, but typically 2,000 plus pounds compression or pressure, and we've got to get that pressure in behind the ring to get it out and seal on that wedge.
Gotcha. Now, so just so everybody's clear, essentially when you're looking at crosshatch, the crosshatch is what retains the oil during the burn process, correct? Right. and then the ring makes, really, it's a liquid seal. I mean, I know people don't get that. Like, there's a lot of people that still to this day think that the crosshatch is there to kind of, like get everything mated together, and then it goes away and the walls are shiny and that keeps things sealed. And that's not what happens. No. Not even close.
No. Not even close. There are coatings out there today that are coming down the pipeline that are molybdenum, what are called flame moly type coatings that go into the bores. Ford's been playing with them. Some of the cup teams play with it. There's some of the import companies that have been playing with it. And those are actually coatings that you will hone smooth as glass. No crosshatch is preferable. But the coating itself is so oleophilic, it sucks up so much oil that the coating itself is holding the oil. We don't have to have a crosshatch there to get it to hold the oil. The coating holds the oil.
So it's like an oil seal sponge.
Say that word again.
Yeah.
Oleophilic?
Oleophilic. Yep.
I've never used that in a sentence.
Crosshatch.
Kind of now.
You can Google it. I didn't make it up.
Oh, I'm sure you didn't, but I'm going to try to use it in a sentence next week.
Clamp my filter down a little. Okay. Wow. Okay. So barring, those particular types of methodologies, then we get into ring materials. Why one material is better than another. Like I stated before, when we were doing a lot of the super stock stuff, it was, usually an 020 dike, stainless with chrome. I know now there's all different coatings, all different materials, things that, came well after me. Could you explain some of the reasons why you would choose a particular, metallurgical compound of ring or coating in today's standards, like what they've learned?
Oh, sure. Absolutely. We'll just say we'll go back through history. I mean, piston rings started off being made out of just generic gray iron, product that's still used to this day. There's a lot of engines that use just a plain iron-based piston ring. The different materials, ideally, there's a couple of reasons for different material. One's manufacturing techniques, and the other is temperature, and most importantly, temperature, the threshold. Like I like to say, heat puts the tension in, heat takes the tension out. there's always a tension point that a ring is going to anneal itself. It's going to lose its tension. A common thing that I have guys do, and this may be off topic just a little bit, but one of the things I tell guys to do is when you're assembling your engine, you've got your little logbook of everything you're writing down. You want to measure what we call the free gap, the open gap of the ring. After you file fitted the ring, if that ring has, let's just throw an easy number out of 500,000, I would expect that ring to come back out of the engine with a similar number. It's going to lose some tension. Let's say it comes out at 420. It lost 80,000. That's very normal.
Mm-hmm.
But if it went in at 500 and it comes out at 200, you got a problem. You either got a tuning issue or you've got a ring material that's not robust enough to handle the heat your engine's generating. And we have to look at using a better material. We're going to lose all the ring tension because the heat is taking the tension out. So
I can honestly say I never checked free gap. So like I always tell everybody, listen, because you can learn something. I mean, I never.
Yeah.
Wow. Good one. Okay.
It's a great condition. It's a great way to look at an engine when it comes apart. If you're taking your engine apart and the ring gaps have closed way up, even though it may still have been performing okay, you've got something that's getting ready to, it's getting ready to give you a problem. But with that said, better materials started to come along. You had ductile iron versus the cast, so we've got a material that's going to handle, again, more temperature. It's more malleable. It will bend without breaking. Cast iron's very, very brittle. So we've got a better, tougher material that's going to handle, some nitrous, a little bit more heat, lower octane fuels, hotter running environments. So, that material came along and has been used for many years and still is used to this day. Then I'll call kind of the next evolution of that is what we'll call a hybrid or hardened ductile iron. Some people know it as like the Hellfire type ring.
Mm-hmm.
Our line is called the TNT ring. It's a hybrid centrifugally spun ductile iron. Again, handles even more temperature, more heat. Bottom line, more horsepower. Got to make those BTUs. So we've got a product that's going to handle a higher temperature threshold. But the downside to iron, from a manufacturing standpoint, is just that. It's iron. It has to be casted. It has to be poured. So it has to be founded. So to keep money and prices in check, you've got to pour fairly large amounts of it to keep the costs involved, costs in line. So when it comes to doing kind of specialty rings and custom ring sizes that are kind of odd, iron isn't necessarily the right thing to do because, again, you've got a lot of material has to be poured, fairly expensive, and at the same point in time, very messy. A lot of that material ends up having to be recycled.
Mm-hmm.
Most piston rings come out of iron-based piston rings, I should say, come out of a thing called a cuff. Looks like a rough casted cylinder sleeve. And as you can imagine, you slice it, you dice it, you ID it, you OD it. All of these processes is removing material. So you end up wasting a very good portion or recycling a very good portion of the material you just had poured. So from that point of view, it's not the best way to do it. Enter the world of steel piston rings. Steel rings are coiled. These come from a big spool wire, kind of like a telephone cable. It's pulled and drawn, and it's literally coiled into the right size. You've got to remember, rings are only round when they're closed. In our case, we cam coil our rings. Not everybody does it that way. Some people round coil and then force the part over a piece of a fixture and then heat treat it to get the cam in it. We actually develop a cam coiling CNC system, so we can actually, when we're coiling the ring, put the right shape on it. The whole bottom line is that we can coil the ring. I could literally, if I wanted, make one ring. Bang, done. No scrap, no leftover, no waste, no byproduct. Very quick, very easy, very quick to make bore size changes. It's all in the computer. It's all in the numbers. So not to say that we're unlimited, but there's not very many limitations as to bore sizes, wire sizes, the speed in which we can do it, very, very little wasted material.
Well, I didn't know the rings came from a coil like that. That's
like a valve spring.
Yeah, I didn't. That's something.
All right, we got more questions.
Yeah, we've got
huge
spools of different materials. Tool steel, stainless steel, as you'd mentioned, 9254 carbon. We can work out of a lot of different stuff, and as long as we have the raw material there, it's very quick and it's a very clean, very efficient manufacturing process.
Hey, one of our guys is asking, tighter or looser on the second ring gap? What's your, Mike and I have talked about this many times.
Yeah.
We know some benefits and some deficiencies, but have at it.
That's a very debatable subject. And what we're talking about is, we're getting into the pressure buildup and ring flutter.
Right.
And that's, that's a very, very misdiagnosed situation. As far as the gap, I generally gap them about the same. My tops and seconds, I'll go in about the same. You got to remember the top ring is going to be smaller than the second ring within seconds of starting the engine. The top ring is going to see the bulk of the heat. So let's just say what we're shooting for at temperature is to have only a few thousandths gap on the top ring to try to get as little going by it. The second ring is naturally going to have a larger gap than the top ring just due to the nature that it's not going to see as much heat. I am personally not a big advocate of big second ring gaps. Have them a little bigger. I don't see it hurting anything. But like everything else, if an ounce is good, a gallon's better. I'll get guys that put a top ring in at 18, and I kid you not, they'll put the second ring in at 60. All that does is get you into more oil migration.
I wasn't quite that bad. I was at like 40.
Yeah, I've heard 50s.
Yeah.
Yep.
It's not a horrible thing. The biggest thing we see is just increased oil migration. We've worked with quite a few places that can do what I'll call long-term steady-state testing. Hundreds, thousands. We worked with MCT and over in the UK. Did a lot of steady-state testing, looking at at fuel contamination, oil consumption, playing with different gaps. And until you get really big, we don't see that becoming a big deal. But when they do get big, you will get into more oil migration. That's pretty much what we saw. I can't really say that I think there's that you have to open up the second ring gap. A lot of people they read the internet and you got to open up that second ring gap. Well, I like to go to, hey guys, internal combustion engines have been around for well over 100 years, and I can tell you my old man 76 Vega, the second ring was tighter than the top ring, and it didn't have any problems.
And I think that's where a lot of this came from. I think a lot of it came from GM, because all of a sudden people started seeing in service specs for, I believe it started maybe with the LT1, the reverse cooled thing, that they had a wider second ring gap. And then people said, GM's got a lot of research, guys. Why'd they do this? And honestly, I think we moved that direction. We didn't see any adverse effects.
I think your dad back in the day said you guys found some power opening them up.
Yeah, well, I mean, I can't say that I ever did because most of the crap that I did was, a lot of the circle track stuff.
Yeah.
So, but I mean, in fairness, most of the things we did at the end with the super stock stuff, they didn't have a second ring.
Yeah, true.
They didn't even have one.
But when they had them, he said it made some power.
Yeah.
And I still think your dad was smarter than you.
The thing is, where I stand on that thing is, if I have to open up the second ring to settle the top ring, I'm looking at the wrong ring. Why is there that much getting by the top ring in the first place?
Well, that's a great point.
I kind of concentrate more on the top. If I've got to put 40 or 50 thousandths on the second ring to, like I say, to settle the top ring down, why is there that much getting past it in the first place? It really takes a very special set of circumstances to truly get into ring flutter where you see that, that differential in pressure. It generally comes on the exhaust stroke. You've got to have an exhaust system that'll evacuate the cylinder fast enough to allow that pressure differential. There's a lot of things that have to happen to make that truly happen. A lot of people, get into bad ring seal and it's ring flutter, where they really haven't looked at blow-by numbers and pressure numbers in the pan to see, are we spiking? Or are we just getting bad numbers? Do I just have bad ring seal? The harder I run it, the numbers are just going up and up and up. Like I say, I kind of concentrate on the top ring at that point. But one of the things that I'll point out, you had mentioned General Motors, and one of the things that I have seen is pressure coming across the ring pack. The OEs, and I know Tom and you and I have talked about this quite a bit, the OEs have got this tremendous battle of fuel efficiency and emissions. They've got to get the tailpipe emissions down. We've got to get more mileage out of the engines. And ways of achieving this are through, a big part of this is reducing friction. You've got to get the friction down in the engine. Well, the biggest friction maker, I'll call it in there, is the oil ring. Mm-hmm. And a way to effectively make an oil ring work that shouldn't work, let's back the truck up just a touch. A 3/16 oil ring from an old 350 Chevy makes like 22 pounds of tension. A 3 millimeter oil ring makes about 10 pounds of tension. Mm-hmm. By comparison, what would be considered a low tension 3/16 oil ring is about 16 pounds. So a 3 millimeter is a pretty light oil ring by comparison. A way of making an oil ring work that's being overloaded or overworked is by putting a pressure across it. Now, in one way, we use vacuum pumps in race engines to help pull that oil down. Well, the same effect happens if I increase the blow-by going across the rings. hence opening up the second ring gap. I'm going to introduce more combustion pressure across the oil ring and effectively blow the oil ring clean. So it's a way of putting a really light oil ring in an engine and keeping that engine dry by introducing a little extra pressure across the oil ring.
Mm-hmm.
That's an interesting concept.
And, in fairness, probably when GM was talking about all this stuff, I don't know that they were into a metric ring pack. I don't know if when all this started. And I can tell you that I think in the Superstock stuff back in the, mid 80s, when people started, looking at ring sides of things, it was a 3/16.
Yeah, you were always in a 3/16.
Yeah, I think that's what it was. Or maybe, maybe an eighth. I don't remember what the, God, that was so long ago.
The racy motors, the eighth.
Yeah, right. Yeah, the good stuff.
Yeah. But
they had the good stuff, and those were still 16 pounds.
Yeah. And I can't even remember when millimeter rings like really came in. Like I mean, it's so bad. Maybe I'm getting that old, but I just don't remember when they started.
Oh, you stayed away from the import.
The GM stuff would have been kind of, mid 90s, kind of, the LSs.
LS, right.
Before the LSs. And, we all remember how good the LSs were on oil when they first came out. And
yeah, I got one.
I definitely know how that is.
All right. Well, actually, a guy, Tad, in studio has a question. Go ahead, Tad.
I got another question, and it's kind of good because you started with the Volkswagens, the air-cooled, the Boxers way back when. Did you ever see a difference with a Boxer engine and needs for a piston, ring sealing or anything like that?
In what respect?
Because it's laid down, he's asking, material,
definitely.
Finish.
Boxer engines are flat motors. One, like you just said, you are dealing with more temperature. They obviously, right, especially the air cools, definitely run hotter. So I like to see a better material go in there. Biggest things with the flat motors is ring alignment, making sure you keep the ring end gaps, what I'll call up high. Rings rotate, and typically with like an early Volkswagen or early Boxers, you had a one-piece cast iron oil ring, and the point of that, it has one end gap. Well, that end gap might end up down at the bottom, might start to get a little oil migration because it's laying in the bottom of the cylinder when it's puddling, but it'll come back around. It's going to work its way back around. Three-piece oil rings, you got to be kind of careful with on a flat engine, because if the rails get down at the bottom, because it is three pieces, if the rails get down at the bottom and they start to move a fluid through them, they'll have a tendency to stay there if you're not cautious. So ring placement, how they're staggered, is kind of important. I always like to see a flat motor with the end gaps, in like, I'll call it the 11 and 2 positions up high, 3 and 9, 11 and 2. So they're up high, they'll rotate, but they'll come back around. Generally don't see too many problems with the flat motors. Crosshatch angles on the cylinders are a little steeper. They're generally about a 60 degree versus a traditional automotive 45. And that helps to return oil back to the sump as well.
Same with a Subaru, like a water-cooled Boxer?
Yeah, absolutely. Subaru, Porsches, that's very, very common to have a more vertical, an increased angle. Off the deck, that's about 30 degrees. What we call the included is about 60. So a little bit, a steeper crosshatch angle, again, it helps to ease in getting the oil back down into the sump.
And actually, we lock the bottom of the two oil rails in one of our return holes so it can spin. And you guys...
That's become a really common practice these days for the flat engine. And it really is a great, simple solution to keep the oil rings from ever lining up down at the bottom of the cylinders.
Yeah, like a two-stroke pen?
No, just so the people understand. Yeah, kind of, but Total Seal puts a tab on the ring that actually locks into one of the drilled oil returns. So, and we configure them at 11 and 2, so you could lock that bottom ring and it won't spin. So you always have one that is closed, and it's always the bottom one.
Interesting.
Yeah. So it just doesn't become an issue. That like I said, when the OE started going away from the old one-piece type rings to the three-piece, that was something that kind of reared its head in the early days. And, locking the oil ring is definitely a simple, easy solution to that.
Yep.
Interesting. See, I learned something else today.
Two things.
Write it on the calendar.
That never happened.
The guy who knows everything didn't know it all.
Yeah. Damn.
Wow. My world is shattered.
You'll be okay.
I know another guy had asked a question before. I don't know if he put it on Mixler or not, but what he wanted to know is what is the proper lubrication for putting an engine together in the bore? And I mean, I had our way of doing things. I'll tell you. And if you say, look, Mike, you're going to learn something else, you're wrong too. Lacquer thinner with a very specific paper towel that, was completely lint free. Wipe and wipe and wipe and wipe and wipe. And when you think you're done, wipe some more until there's not a hint of any kind of material coming out of that board, that it's as absolutely clean as humanly possible in all the crosshatches. Generally, using a tapered expander, 1030, whatever your favorite oil is laying around when you're putting the motor together, ring around the expander with your finger, put the piston through, maybe a touch of oil on the skirt, and that's it. We never oiled bores, never did anything like that. So what's Total Seal's official position?
Less is more is absolutely, everything you just said is correct. I'm a lacquer thinner and those like blue kind of towel things that you buy at the, the home stores.
Yep. We had a particular one that was made by Scott, and it used to be a Scott like 05320, and they were like kind of like a spongy looking, but it was a paper.
Are they paying us?
No. They should.
Well, they should.
Because I'm sure, like he said, 1% of all the rings are used. I'm sure 1%, probably 0.25% of Scott towels we used to put motors together.
I'm calling Scott tomorrow.
But they didn't leave any lint, and they were white, so you could really see what came out of there.
See it exactly. When the lacquer thinner flashed off, that's what I tell people. You keep cleaning it. Use a clear solvent like a lacquer thinner. I like lacquer because it flashes off quick. When it flashes off, and the only thing left is a clean white towel, you're good to go.
Mm-hmm. Mm-hmm.
When the lacquer thinner flashes off and you still got, stain marks all over the thing, keep cleaning, Chief, because you're not done.
All right, what about ATF? Because I was always, whenever I built them, I would go through it with ATF, and no matter how clean you got it with lacquer thinner, the ATF always seemed to get something else.
But yeah, transmission fluid works well. It's high detergent. Anything that's a high detergent type product will help to pull that junk, that dirt, that just the grit, the grime. A high detergent product will definitely help that. So whatever it takes to get it, to that point where you feel it's really clean. As far as the assembly lubricants, you had mentioned ATF. I don't like transmission fluid. Transmission fluid today has a lot of friction modifiers, clays, things like that in it. You and I, we all grew up wanting the thing when it shifts gears to knock our head off. Today, no one wants to feel that. They want this nice, smooth. There's lots of modifiers in there. We don't want that stuff. We want something that burns off clean, quick, leaves no residue.
Mm-hmm.
We do have some dedicated assembly lubricants. We have what we call our Quick Seat product, which is a dry film lubricant.
Yeah, it was a powder, right? Wasn't it like powdery?
It's a powder.
Yeah.
Yep. Very thin, very light, coating of that. It's about 400,000 pounds of pressure ejection. And we also have what we call our AL8, which is a liquid lubricant. But with all of those, everything you hit the very first time, less is more. It doesn't take much. Very, very little. Very tiny, very fine. If I'm using an oil, I look in the cylinder. I don't even want to see an oil. I want to look in there. If I put my finger to go, oh yeah, there's a little something on there.
Yeah, exactly. Like when we did it and you would put a piston in, you might see like an oil trail because you didn't have enough to where it made like a uniform coating around the cylinder.
Yeah.
There's not enough on it. And like you said, finger dab on the skirt. Oh, as you're putting the rings on the piston, if you got a little oil on your fingers, hey, that doesn't offend me. But that's it. A less is more scenario. This, stuff dripping out into the drip tray and dump it in a bucket and all that. This is not 1950, folks.
And for the guys that I always pick on our hillbilly listeners, that means you do not take the pistons and dunk them in your favorite 50 weight Kendall racing oil. Okay, don't do that.
Absolutely, don't do it. It's the lubricants are so good. The ring tensions are light. If you think about it, you have the old 564 stuff like we talked about. Those rings the compression rings make 7.5 pounds of tension. You've got oil rings that make 20 plus pounds of tension. You're dealing with blocks at the time that are, we measure block hardnesses in Brunel that are, 150, 160 Brunel on a good day. So you can miss it. You could put some goofy fluids in it, not get the cylinder finishes just right. You know what? The rings have got so much tension, the blocks are soft. It's going to eventually come in. It's going to seat up. In today's modern world, we're dealing with blocks that range from 220 Brunel to sleeves that are over 500 Brunel, and we're dealing with rings that literally make a half a pound of tension, and oil rings that are 3, 4, 5, 6 pounds. Now, we use a weird lubricant when we're putting that together. We've got a cylinder finish that's not right on a really hard block. Well, eventually that ring is going to correct those mistakes. Eventually it will do it, but probably not in your lifetime.
So for the most part, guys putting motors together, slight amount of oil, like no Marvel, no ATF, no nothing weird. Just clean it nice, clean it as well as you can. When you think you're done, give it another pass, because it's almost never, ever good enough. You make yourself neurotic trying to do it and lay off the custom fluids. Probably not a great idea.
Yeah. I say, what goes in an engine? Engine oil, and that's what you put them together with.
Yep.
Makes sense. All right, one more question.
Please.
I could keep this guy on for
I know,
because
yeah,
I've got all kinds of
I know.
high level shit that I want to start asking.
I got all night.
Well, we might have to have him on again. But anyway, so I got a guy asking E85 or other alcohol-based fuels washing cylinders. What do you see with regard to rings for those applications? Anything different or different cylinder finish?
From a ring point of view, no real difference there. E85s or alcohol engines were running, as we like to say, copious amounts of fuel through it. When we talk about cylinder finish, the old days of talking RAs and things like that, or talking about honing stones, are really, kind of, Fred Flintstone kind of stuff. That's not what we look at anymore. Again, we're dealing with such a wide range of block hardnesses, different ring materials, different, lubricants. We look at numbers that are called RPK, RK, and RVK. And the RPK is the peak roughness. This is the roughness of the finish that actually touches the ring, would protrude through the oil film. RK, which is the core roughness, which is the area that actually supports the load. You got to remember, the cylinder wall is a bearing surface, just like a bearing on a crank. It's got to support a load. So there has to be something there to support that, meaning hold the oil up. Then you have the all-important number, the RVK, the valley depth. The valley depth is what gives the oil the ability to cling to the wall. Even though oil is being thrown on that board, doesn't mean it's going to stick to it. Think about driving your car, water thrown on the windshield, wipers wipe it all off. Well, rings are trying to do the same thing. They're trying to put the oil back in the pan, but we've got to give it the ability for that oil to grab onto the bore and stay on the bore, keep the rings lubricated, keep the skirts lubricated, and that's the valley depth. And that number becomes extremely critical when you start dealing with the 85s, methanols, fuels where we're putting a lot of it through the engine. We have to make sure that RVK number is higher or high enough to give that oil something to grab a hold of. And that's a common issue with engines of that nature. We don't give it a deep enough valley. And I don't mean a rougher cut, I mean a deeper cut. And that's done through different honing techniques, more pressure, different medias that we're honing with. So, yeah, when we're dealing with E85s and alcohol, cylinder finish becomes very, very important. The other thing that you want to do is, especially on initial run-in, a fresh engine and a fresh set of rings is extremely intolerant of a fat fuel curve. It's really easy to burnish a cylinder when you first fire a motor.
Yep.
And I hate saying it, guys, a burnished cylinder is never coming back.
Yeah, not coming back in.
Got hurt. It's the cylinder that got hurt. And the only way you're going to bring that back is to, take it apart, re-hone it. Like, I've seen them 1,000 times. The rings are fine. They look brand new. You fluff the cylinder up, put it back together, but again, the last thing you want to do is have an overly fat mix on a fresh startup.
Yeah.
Now, the specifications you talked about in honing, would they vary based on oil control methods, like using an edge or a Napier type second that is such an efficient oil wiper, or no?
No, really, when it comes to what I'll call the honing recommendations, the numbers like we just talked about, peak numbers, core numbers, valley, it's really application. What are we doing with it? If I've got really thin, very, very light drag rings that have no tension, the bottom line is they need less oil on the bore. All these numbers, if you really kind of work them together, come down to volume. How much oil am I asking that wall to hold? So as the ring tensions go down, we're dealing with normally aspirated stuff. I don't need as much oil retention on the wall, so I'm honing to have less. And it goes just the other direction. As my cylinder pressures are going up, the amount of fuel I'm putting through the engine's going up, I have to have more volume of oil being held by the bore to hopefully survive that environment. If I'm dealing with, 3 stages of nitrous and 28-pound oil rings and, those kinds of environments, I've got to have a lot of valley number to give that oil something to grab a hold of. Otherwise, I'm going to go dry. And now I've got black death. I'm tearing the skirts out of it. I got blow-by problems because I've got no fluid to seal the ring.
Okay.
All right.
And I have anybody that wants to drop me an email or contact me, I can give you those numbers where they need to be. Find a local machinist that's got the equipment. The profilometers and the tools to measure this are not that uncommon these days. lots and lots of guys have them. The numbers really don't change that much. I'll say this: I've got 3 basic groups of numbers, depending on what it is you're doing, and the numbers really don't change. It's how you get them. That number, let's just say that number is a fairly fixed number. How I get that number on an old 350 Chevy block versus how I get that on a dart block versus how I get that on an aluminum block with a dart and sleeve is 3 completely different honing processes. Yet at the end of the day, I still want the same numbers.
Okay.
Well, we can have our guys ask us if they want some info from you, because I'd be afraid to give them your contact information.
I'd like a sponsorship from Total Seal.
Yeah.
We'll just say if you go to TotalSeal.com, you can find my email address.
Yeah, there you go. All right, off the record now. How's the Pro Stock deal doing? We know you guys have a car.
It's coming along. It's coming along. Matt's got a brand new car. They got a brand new Jerry Haas car that
he finally got it?
And Matt's a very, very dear friend of mine, but in typical Matt style, stuff always kind of shows up last minute. They got the brand new car the week of Pomona, as well as the engine for the car. So it's amazing how much he does with so very little time. And they got the car together, they got it to the track, they qualified Pomona, they qualified here for Phoenix. But as with many of the Pro Stock guys, they are definitely struggling with the EFI right now, drivability issues with the EFI, and a brand new race car. So they're still kind of sorting that out. I know the car's back east right now. They'll definitely be at the Gators. So hopefully they've got, they'll have things kind of sorted out by that point.
Good. It's good to hear. Tell Matt that I said good luck out there. I saw him in Cali. I'm not going to be in Florida.
Appreciate that. They are, we'll just say, mad thrashing this thing.
Yeah, I know. I'm going to miss the Gators for the first time in like 22 years.
And I hate to admit, I've never been to it. I'd love to go to it. I've just not made that race.
You should go in my place. They need one of us out there.
Exactly. Somebody's got to be there. What's going on, huh?
Yeah. Well, you've been a fantastic guest, man, which I knew you would be. I think we could spend another 2 hours.
But I've got like
I know,
75 more questions.
I know you do. I know. Hey, I'm gonna say it now. You have an open invitation. I mean, there's plenty of stuff we can go over with you. If you want to come back on, we'd love to have you. Why don't you give Total Seal?
And I'd love to do so. I'd love to answer any questions, whether it's about just anything, general stuff. Our rings, somebody else's rings, this, that, cylinder breaking, like I say, just let me know what you want to do, and glad to come back on.
That's awesome. Well, we'll get plug Total Seal for the boss man.
Absolutely. Well, Total Seal piston rings, we're the home of the gapless piston ring, and I can tell you this: we're striving to make every piston ring, gapless, conventional, any type, the best product it can possibly be. Come by TotalSeal.com and check us out. We've got our new Total Conform rings that we brought out at the PRI show. Check the website out, and then drop me an email. Let me know what your questions are.
Fantastic.
That's awesome.
No, I mean, like Tom said, we have kind of a group of people that we always welcome back. Like JC from ATI, he's got to come back.
Yep.
That because we scratched the surface there too. I feel like selfish. Like I'm getting like basically if you called a guy for a sales guide, I'm not saying this about you, Keith. I'm not. But could you talk to a guy for 2 hours or an hour during his workday? I got a question, and then.
We'll just say easily.
Yeah, but then you're the guy. It's like, oh Jesus, I got to get this guy off the phone. I got 40 other people waiting to ask me, what should my ring gap be? So this should be really educational for a lot of people. And I mean, really, don't squander these chances. If you got questions, send them in, because these are questions that everybody could get answers to that they wouldn't normally know how to get. I mean, this is great.
Yep, no doubt.
And just to say, we're a resource. That's what we're about. I mean, one of the things that we deal with every day is we're the piston ring, and I know other people in the industry will feel the same way I do, but I like to call us the redheaded stepchild. We get blamed for everything. It's got this going on, it's the ring. Flat tire on the way to the track. It's those darn piston rings. So we have to kind of have a fairly wide knowledge base of different things. How things are, what happens, how things interact, because it's all got to work together. Pistons, rings, cylinders, oils. I mean, all of this has to work together, and if there's one part of the chain that's faulty, guess what? We're getting blamed.
Yeah.
and I know other people think they're the ones getting blamed too. So, we are definitely a resource, and we're here to help share that knowledge. And there's a lot of what goes on that doesn't really get discussed. It might be talked about between two friends, but not in an open forum.
Gotcha.
Well, we're going to have you on again. probably sooner than later. And I really appreciate you coming.
Yeah, definitely. Thank you very much. It was really good to have you.
Anytime, gentlemen. You guys have a great evening.
You too.
Thanks.
Thanks, Keith.
Thanks, guys. Talk to you later.
See ya. I have so many questions.
I know you're like a kid. You look like a kid 2 days before Christmas.
I want to
you look
know, I mean, I can't tell you how many people, and you had it wrong in your catalog too forever, unless you changed it, ring gaps. Like if people use what
I know.
what it said, they call you up and be like, look, I don't know what happened. All my rings are bad. Yeah. Well, no, you read our catalog and you capped accordingly.
Yeah.
I mean, it was in sealed power forever.
Right.
And we knew you couldn't do it.
Right.
I mean, now I looked at their thing. They used to be kind of wrong too. That's altered as well. I don't know when that was corrected, but I mean, I guess everybody's got their opinions, but my thought was always if you gave yourself a little more top ring gap, mistakes happen. You're going to get hot. You're going to get lean, you know, and it's much worse to have a ring get jammed up.
Right.
But I mean, there's so, like top, radial clearance, axial clearance.
Tons. Well, we didn't even talk about axial clearance. No. I mean, which is really cool because we were on the cup stuff for a while in pro stock. Axial clearance in a regular axial's top to bottom, guys. In a regular motor,
you beat Alan to that.
Yeah, I know.
Axial means
yeah. It's 2000s 2 plus 2.2 whatever, and pro stock guys and NASCAR guys are in 5 6/10. Talk about having to be flat, a piston, a ring.
Under heat of expansion, everything moving.
Talk about measuring everything in a couple of places.
Wow.
But we got a lot for him. I told you he'd be good.
Yeah. I mean, super interesting too, to know that all the rings, and listen, when I said lapping doesn't work for anybody that was on there saying, oh, well, some machinist you are. No, listen, because a guy that would normally lap would take something in his hand that was cut to hold a ring, go and rub his,
or just his hand on him. He'd get his Coke mirror.
Yeah.
Put some 600 on it.
It's
and
like
then,
somebody said in there,
I don't think the logo on the mirror has anything to do with it.
Yeah, I know.
But I mean, you can't do that. You just can't.
No.
So, I mean, the way that they do it.
Well, there used to be fixtures for it too, on a granite. But yeah, of course, the way they do it, they do it the right way.
Yeah. I mean, but that's really interesting that they do that. And I guess that really is the only way to hold tolerance.
Yeah. Well, listen, there's a lot of people that still pick up a couple tenths here and there just on a granite plate with some 600 and they make something, that's flat on top.
Yeah.
You got to do it. You got to do it.
Right. I mean, what we always did when we did anything like this is that we would hit the top side. We wouldn't hit the ceiling surface. Yeah. Again.
So you'd make a glass block or something that you knew was flat, aluminum, whatever, and make a sanding block.
Right. And we'd always assume that the more important surface was the surface you weren't touching. So you didn't screw up the bottom, if we were just trying to make a little bit of room.
That makes sense.
That's how, but I mean, I've seen people do this. And, they've got like an aluminum puck is what I always called it, like a piece of bar stock. And they cut like a deal to hold the ring.
Right.
But then as you're running it around, you can't help but lean on it.
Right.
You need something so stable to do that.
Right.
But like learn about the manufacturing, the fact that rings are coming now in coils.
I know you learned 2 things today.
Yes, I did.
Not to mention all the shit I teach you during the day.
Oh, yes. Countless loads of information.
Yeah.
Loads.
All right. Fucking genius.
All right. Well, we got to get him back. We got to get JC back from ATI.
Hey, can I shout out to Amy again?
Sure.
Okay, I just did.
Okay. I'm sure she's appreciative.
Yeah, we were in Florida for a couple days, and look, just by happenstance, she went down and got a job, really good job,
and who's Amy?
She's a cousin.
Okay. Well, I just figured it should be clear that it wasn't some.
She's great. We had a great time. She's just good.
Trying to keep everybody's minds out of gutter. That's
I just got to say one more thing.
Yes.
The dimmer switch.
The dimmer switch.
Don't worry about it.
Okay. All right. Well, there you go. On that cliffhanger, I guess we're out of here.
Thanks, everybody.
Tad?
Yes.
Yeah, I know you tried, and I know you had questions. I know. I'm sorry.
Well, he
I'm
covered.
monopolized.
Tom took one of them, so.
I know.
I did?
Yeah, you did.
By accident?
You have to be a little more assertive, Tad.
Sorry, man.
Perhaps you're
Tad,
not.
you look good anyway.
You're not quite.
That's the important thing.
So, I mean, but keep some of your questions for next time, and you can get some of yours in. I mean, like I want to know about diesel rings. I mean, that was another thing we talked about.
Next time, he said.
Yeah,
gas porting.
Yeah, gas porting. So many things.
I know.
So many things.
We'll get it.
All right. Well, next time we don't know who's on. We'll figure something out. Keep an eye on our Facebook page.
Yep.
And we'll keep everybody informed.
Oh, yeah.
See ya.
Later.